Hello everyone, my name is Uncle Gary, and I am here to teach you how to make the DVD bouncing logo screensaver. You've probably seen this in some memes in the past couple of years. If you're old enough, you've probably actually seen this on a DVD screensaver. So let's get right into it and start off with a new project in Lens Studio. Alright, I've already imported some things that we will be using in the project, starting off with the DVD logo here. Alright, so the first thing we're going to do is add that as a screen image. And let's actually make a material for it, because we're going to be adjusting this material a little bit later. Let's just title this DVD, and let's add that texture to it, and then add it to our screen image. And you'll see it's kind of messed up right here. That's just because the blend mode is disabled. Let's turn that to normal, and there we go. Let's name this DVD, and then also let's just add a new screen image and set it to fill, and let's add another unlit material, and let's just call this background, and we will set this color to black, and let's name this BG. We'll add that in there and then just drag it above the DVD. And now let's resize the DVD. Ooh, not the background. Let's resize the DVD image here. That seems like a pretty good size. Alright, so now what we need to do is create our script. So let's go in here and add a new script to the resources panel. Let's just name this DVD controller. And let's add that to our scene. Okay. Alright, so first thing we're going to want to do is import our DVD screen transform as well as the material. So we'll start off with the screen transform. This is going to be how we move the DVD around in the screen space. So let's just call that DVD. And then let's also import the material. And we'll just call that DVD matte. Alright, so let's find that screen transform here, and then let's drag the DVD material here. Alright, so now we are set up. So the first thing that we're going to want to do is, I guess, let's figure out how we're going to be moving this, and that's going to be using the screen transform's anchor property. You'll see if I do like script.dvd accessing that screen transform.anchors, and then specifically set center. So what this is going to be doing is it's going to take in a vector2 value, and based on that value it's going to place the image or screen transform of this image somewhere on the screen. And the vector2 values are x and y. So x would be the horizontal, y would be the vertical, and they are normalized between -1 and 1. So if we were at 0, 0, it would be at the center of the screen. Let's try that. So to put a vector2 in there, we would do new vec2, and then in parentheses we would put in our x and our y values. So let's just put 0 and 0, 0 comma 0, and you'll see that it'll snap it to the center, which I think it's already at. So maybe let's try something else, like -1 and 0. Yep, so you'll see now it's on the very corner of this. And what you'll notice now is that it's going past the bounds of the screen, because this is actually sending the center of this image to that point. So what we're going to need to do is do a little bit of kind of guess and check work to find the bounds of this image corresponding to our screen. So let's I'm going to disable this BG thing here so we can kind of see the edges better, and let's just start putting in numbers to figure out what the best one would be. So let's go with like 0.9 first for the right. That's too far. Let's do 0.8, still too far. 0.7, alright, that's good. So maybe like 0.74, oops, 0.74. Okay, yeah, 0.74 looks like the edge of that, so that would be our x horizontal. So let's create a variable and call it horizontal bounds, and that will be 0.74. Alright, let's put this back to 0, And then let's get our verticals. Let's again start at like 0.9. Actually, let's go negative 0.9 so that we can see it a little bit better. Yep, there we go. Okay, so that's not enough. Let's go 0.95. Too much. Maybe 0.2. Not enough. 3. Maybe 4. That's a little bit too much. So 3.5 or 3. Yeah, there we go. That looks like about it. So that would be our vertical bounds. So let's do variable vertical bounds equals 0.935. All right, so now that we have those, you'll notice that I used the negative here, but I'm putting the vertical bounds as a positive number, and that's because all we would need to do to change this is to add the minus symbol in front of it. Okay, so now we have our horizontal and vertical bounds, but wait a second. Let's see if we change this preview to like the iPhone X, and let's try that here. So like let's do horizontal bounds and see what happens. So you'll see that it's actually not on the edge correctly because the iPhone X and some other phones have different aspect ratios. So what we're going to need to do is find out, based on what device you're using, what the aspect ratio is. And to do that, let's add a camera input. So we'll input the component camera and we'll call it cam. Let's use our orthographic camera. I'm not sure if it matters which one, but we'll just use that. And then let's do a turn on event. This is how we're going to be detecting, once the lens turns on, how we can find out what that aspect ratio is. So I'm going to create a function. I'm going to call it turn on. And then let's bind that function to the turn on event. So script.create event, turn on event, and then .bind, and we're going to bind that function turn on. Okay, so now once this lens turns on, this will happen. So let's first let's find the aspect ratio. So I'm going to create a variable called aspect and set that equal to script.cam.aspect. And let's just print it out here so that we can see what it pulls up as. So you'll see that on the logger here we have a aspect ratio of about 0.488. And if we go back to like the no simulation, it's like 0.56. Maybe like the iPhone 8 is even 0.56. 0.5625 is like the standard that has been the same for a while for most phones. But the iPhone X and the I believe the LG, yep, they were the both first ones to kind of change that. So I think what we can do is make a if statement. If aspect is less than 0.5, oops, not greater than, less than 0.5, then we can change that the horizontal and vertical bounds. So first, I guess we will want to test these out. So now that we're on the, let's just do the iPhone X one. Let's test these out. And actually what we can do is we'll just put this right here in the turn on event, and then let's change the horizontal bounds to, looks like it's a little bit too far now, so let's go like 0.7, or let's go 0.8. Oh, no, sorry, 0.7. It's still a little bit too far, so maybe like 0.69. And yeah, that looks, well, there we go, that looks pretty good. 0.068 would be good for that. And then let's turn this to 0. And then this one, vertical bounds. See how that looks? Okay, that's way too far. Let's make it go to the bottom actually. So here we can just put negative vertical bounds. And that actually isn't too bad. It might be easier if we do the LG one. Maybe a little bit easier. Actually, that might be fine. Let's see. Vertical bounds. Yeah, we can do this again. Yeah, that's actually not too bad. Maybe just like a tiny bit more, so like 0.936. And let's try negative again. Maybe like 9.4. Yeah, okay, so like it's very, very small differences, but this is how we're going to, I mean, this is kind of tedious, but this is how we're going to be able to make sure that this works for all different phones and aspect ratios. And also, because I like to make things work for Snap Camera, we're going to do the same thing for the horizontal preview. So let's, and if we look at horizontal, that aspect ratio is above 1. So we're just going to do if the aspect is above 1, then let's change those vertical and horizontal bounds again. Horizontal bounds. Let's go back to 0 with this and do horizontal bounds. Okay, so I'm guessing that we're going to need to make the horizontal bounds a little bit larger this time. So let's do 0.9. A little bit too far, so maybe 0.85. Not enough. 0.88. 0.87 looks like it'll probably be the right one. Okay, so that's good. Then vertical bounds. Let's go back to 0 on this. And I'm only putting these back to 0 so it's easier to see from the center of the other one. So yep, that's going to be a little bit too high. So let's go with 0.9 instead of 9.3. Yep, too far. 8.6. Oops, there we go. Not enough. And what you're seeing it change is because I'm just doing Control S every time to save the script so that I can see the changes happen. And 0.88 seems pretty good. Okay, so now we have our vertical and horizontal bounds hard-coded based on the aspect ratio. So now we are ready to set those. I can take this out of here and we'll just have it set to that default thing. Let's create a function here to set it at a random position on the screen when it starts, just so that it doesn't always start from the center every time you open it. So we'll call this set random position, I guess. Should be fine. And to do this, we're going to create a math.random statement. Math.random is a JavaScript function that basically picks a number or a float between 0 and 1. So it could be any decimal number between 0 and 1 if you do math.random like this. So let's call this, we're going to do find a random variable between the negative horizontal bounds and the positive horizontal bounds, as well as the vertical for each one. So I guess we'll do variable random, or you know what, actually all we would need to do is create a position variable. So let's do variable x position. We'll just do x pause because that'll be quicker. And then y pause. Okay. And then we'll just set that variable here. So x position equals math.random. And if we do this, it'll just be between 0 and 1. But what we want it is to be between -1 and 1. Actually, between the negative horizontal bounds and the positive horizontal bounds. So what we can do is just add negative horizontal bounds here before it, and then add that to the number. And this will still get between this will still go between 0 and 1, this number right here. But if we do multiplied by the horizontal bounds, then it'll be between 0 and the horizontal bounds. So now this will actually be between negative and the positive horizontal bounds. And then we can do the same thing for the y position. So negative vertical bounds plus math.random times vertical bounds. All right, and now let's set that position. So we will do script.dvd.anchors.set center, and then that new vec 2. And this time it's going to be, come on, it's hard to do this when I have the microphone in front of my face, but we have x position and then y position. Now if we add this to our turn on function, set random position, there we go. Now it'll be picking a random point, and it will never go past those bounds, even if we change it to like this one right here, or even the iPhone X. Yeah. All right, cool. So that's good. We have our random position. And now that we have our x and our y positions as variables, we can start using that to change those positions. So let's create an update event. And the update event is going to be what we do every single frame. And in that update event, we're going to pass something called event data. that is how we're going to get the delta time. And basically what delta time is it tells the lens or the code how much time has passed in between each frame. And we can take that information to basically to normalize our speed based on different devices with different frame rates. So if you have a slower device, it'll still go at the same speed because it will account for that extra time in between the frames. Oops. Script.create event, update event, and bind that to our onUpdate function. All right, so the basics of this is just going to be, we're going to be adding to our X and our Y positions by a certain speed. So let's create a speed variable for both the horizontal and vertical positions up on top. We'll do input float because it's going to likely be a number below 1. We'll call this X speed. I'm going to just set it equal to 0.2 as a default. We can always change that in the inspector if we want. Float Y speed also equals 0.2. There we go. Those pop up right in the inspector, so we can always change that if we want just by moving it around. And then in here we're going to be adding that speed. Actually, what we should do is create a variable X speed equal, and then just grab that variable from the input right away and set it to our own variable, because we're going to be changing this as well throughout the script, so it'll just be easier than typing script dot every time. Okay, so now we have that, so now we can just do plus X speed, and then here we're going to be multiplying by event data dot get delta time, and this is what I was talking about before, where it'll account for different frame rates. We'll do the same for the Y position. Plus Y speed times event data dot delta time. Get delta time. Just trying to save time here, I guess. All right, so if we do this, and then we again set this position, you'll see that it's just going to be constantly moving up. And now that I'm thinking about it, I'm going to actually just create a separate function for this. So I'm going to call it move DVD. Just copy and paste this into that function. And then this will just say move DVD here. But then also, because we're passing in the event data from there, we'll have to use that as a parameter as well, and make that sure that this is in the parameter here. So now it'll do the same thing, just constantly move up. But I guess also you'll see that while we're getting the random position, we're not getting a random direction for it to move. So to do that, we can kind of do the same thing in our set random position. We can get a random number between, well, this time we're going to need to get a random number between basically two values. And to do that, we're also going to use the math random function, but instead what we're going to do is a little shorthand if statement. So let's do, we'll just call this random variable, like random x, and then we'll set that equal to math.random. And right now, again, this is going to be grabbing any random float between 0 and 1, but what we're going to do is if this is the shorthand, so if this is greater than 0.5, basically this will get like half of the time it'll be above 0.5. Then we'll add a question mark, which means if it's greater than that, then the first value would be 0, and if it's not, then it'll be 1. So now this will basically be grabbing a random variable or random number between 0 and 1. Or I'm sorry, it'll grab either 0 or 1 randomly. So let's print this out just to show you. Random x, and then I'll just comment out this aspect ratio here. Alright, so if I save that, 0, and if I just keep testing it here, see sometimes it presses 0, sometimes it does 1. Okay, so that's working. Let's do the same thing for the y. I'm just going to copy this and then change that to random y. And now we can do just a short if statement here. If random x equals 1, then we will set the x speed. We'll just multiply it by -1 so that it'll change to 0. We could also do x speed equals negative x speed, but This is a tiny bit shorter, I guess. So multiplied x speed equal, basically multiply the star symbol and equals basically means x speed equals x speed multiplied by, and then -1. And then we'll do the same for the random y. So if random y equals 1, then the y speed will be multiplied by -1. Okay. And then this should, yep, so now we'll see that it's picking random directions as well as random positions every time. Perfect. All right. But it's still just going past these bounds, so we need to fix that so that it bounces off of those. And in this move DVD thing here, what we're gonna do is basically simply just do x position, or I'm sorry, if the x position is greater than or equal to the horizontal bounds, or, which is these two straight lines, if the x position is less than or equal to the negative horizontal bounds, then we're going to negate that speed so that it goes the opposite way. So this will be x speed multiplied by -1 again. And we can do the same thing for the y. I'm just gonna copy this, make it a little bit quicker. So y position, vertical bounds, y position, and y speed. Okay, so if we save this and we see this going, it should bounce. Oop. That is not working. What did I do wrong here?
5 minutes later.
Oh, it's it's because I didn't set these to -1. I just set them to 1. There we go. Yeah, there we go. So now it's bouncing. So this would be easy enough to do, but I did notice, and I might not be able to replicate it here, but sometimes when it hits the edge, the number is so small that sometimes it'll go past that, the bounds, but then before it can go back upwards or away from the bounds, the next frame it'll still be in the bounds, so it'll kind of like jiggle back and forth until it gets to the other corner. So let's speed this up and see if we can replicate that just to show you what that would look like. This might take a little bit, but sometimes this could happen. No, not happening yet. It might not happen, so if it doesn't, then you'll just have to take my word for it that this could happen. Oh, there it goes. Right there. So the way that we fix this is to, basically what we need to do is set the x position to those horizontal bounds first so that it can't overlap. And to do that, I'm going to actually take this out of here and just add a different one. So first, if it's greater than this, then the x position will equal that. And then else if, which means it's basically checking this. Otherwise, if this isn't happening, then we'll check this. So then if x position is less than or equal to negative horizontal bounds, we'll do the same thing here. However, this will equal negative horizontal bounds. And then we'll do the same as well with this. Here, copy that, go here, else if, and make sure that it's set the y position equal to the vertical bounds on this one. And then, oops, we need to make sure that this is less than or equal to negative vertical bounds, and then set the y position equal to negative vertical bounds. And now, no matter how fast or how far it gets outside of the bounds, it will not get caught on that. So now we're good with that. We fixed that tiny little bug. Let's set it back down to a smaller number. All right, so now if you remember, if you've ever seen this thing happen in real life, you'll know that the colors change every time it hits a side or corner. So let's do that right now by adding a different function. We'll call that set random color. And we're going to be using just the simple math at random this time. getting a number between, or a float between 0 and 1, because with the code, when you're setting a color value, the RG and B values are between 0 and 1. So variable R equals simply math.random. Same with the G. And then the B. All right, and then all we need to do is do script.dvdMaterial.mainPass. This is how we access all of those properties. .base color, and this is going to be a vector 4. The first 3 vectors are obviously going to be the RG and B values, but the 4th value is going to be the alpha, so like its transparency, and we'll just set that to 1 always, because that's just there's no reason it would not need to be fully transparent. So every time it hits one of these walls, we're going to set a random color. Let's just copy and paste that into each one of these if statements. And once we save and watch, boom, boom, yep, random colors. Now it's looking like a bouncing DVD screensaver. And I guess, I mean, this is the basic lens, the functionality of the lens, but one thing that would be really cool is to have something happen if it actually hits the corner, because we all know that's what everybody wants and is waiting for. So to do that, let's do another function, and we'll call that check corner. And this is just going to be a very long if statement, basically. So if the x position is greater than or equal to horizontal bounds, and, which is 2 and symbols, the x position is less than, or I'm sorry, and the y position is less than, or no, we'll do greater than or equal to vertical bounds. And then after that and statement, we'll do or, so if that case, or this case, which is going to be x position greater than or equal to horizontal bounds, and the y position is less than or equal to the vertical bounds. So we're just basically going to be doing an if statement for every single corner. So if it hits any of these corners, then we'll do something. So next we'll do x position is less than or equal to, then negative, oops, and I need to make sure that this is negative as well, equal to the negative vertical bounds, or horizontal bounds. And y position is greater than or equal to vertical bounds. And our last or statement, if x position is less than or equal to negative horizontal bounds, and y position is less than or equal to negative vertical bounds. All right, so if this happens, I guess first we'll just print something to show us in the logger that it actually is possible. It hit the corner, oh my god. Okay. Because we very likely might not see this with the speed it's going, I'm going to boost the speed up a ton just to hopefully get us to see it happen quicker, because it could be hours before it actually happens since it's randomized. While we're waiting for that to happen, we can add some stuff to actually put in here when it happens. So I added a couple things here, a little crowd cheering effect. We'll just call this crowd. We'll add that audio track, and then we'll input that here. So input audio component, we'll call that crowd. And then we'll also input a scene component, because we're going to be adding some confetti particles. So scene object confetti. And then let's go back here. We'll add those to our screen. And let's also add a particles material here. You know what? We're probably going to need to put this on a different camera so that it pops out in front. Let's create this and call it... Actually, looks like it'll work on this camera. Okay. And then we'll just put our confetti particle material here. There we go. Looks like that's working just fine. One thing you might notice that I've noticed in the particles is that sometimes if you move them too far, like above or outside of the scene, they will kind of disappear. And if we go into the particle materials, we'll just go to the default to show you what it looks like. Like right here, it's fine, it's visible, but as soon as you move it too high up, they disappear. And to fix that, all you have to do is go to the frustum culling setting, set it to extend, and set it to like a large number, like 50,000. And that should do it. That should fix it. So now it shows up regardless. Cool, so that's on by default. Let's change it to first just not be on by default. So script.confetti.enabled equals false. And we gotta make sure that that's actually set up in our script. There we go. I'm just gonna move this above the script for organizational purposes. All right. Now we have that going. Now we can put that in our if statement so that first let's play that crowd cheering once. And then let's enable the confetti. It's true. Cool. That is our basically our win scenario. Let's see if this happens here. I might have to speed up the the video just to make sure that you actually see it. So I guess I'll be back in a little bit. Oh, you know what? I realized that I didn't actually put this check corner here in the update statement. It would be useful if we actually ran this function every frame. There we go. Now we will be back in another 15 hours.
One eternity later.
Oh my god, it happened! It happened! Oh my god! Okay. Okay. It works. Okay, well, it's been a long time, so that is going to be the end of this video. Thank you everybody for sticking with me. Tune in next time for another Coding with Uncle Gary video. I'm gonna go get some much needed rest. Goodbye, everyone.